Assalamualaikum warahmatullahi wabarakatuh. The next topic is spring constant, K. We need to know what is the definition for spring constant. I'm going to read it for you. Please jot it down. Spring constant K can be defined as the force that is needed to extend a spring by a unit length. Okay, that is the definition for spring constant. And as I told you from the previous video, that the gradient of fx graph is the spring constant of the spring. Now let's say there are two springs here. We have M spring and N spring over here. You can see here when we apply 20 Newton for M spring, then we have 5 centimeter extension. But for spring N, we just need to apply 10 Newton force to produce the same extension, 5 centimeter. So how do we understand this situation? First, we need to find what is the spring constant, as we know that formula for Hooke's law is F equal to Kx. So for spring M, let us try to calculate spring constant. F over X. F is 20 Newton divided by 5 centimeter. So the spring constant for M spring is 4 Newton per centimeter. For N spring, it is 10 Newton for 10 Newton over 5 centimeter. So you have 2 Newton per centimeter. That is the spring constant for spring N. So look at the number here, 4 and 2. Okay, how do you compare this? So from here we understand that spring N requires only 2 Newton to produce 1 centimeter extension. So we can understand that it is less stiff. So we can say that N is less stiff than M. So the gradient of the graph, or the spring constant, we can say that if the spring constant is higher, the spring will be stiffer. So please understand that. Okay, maybe I can visualize something like this. Let's say this is spring M. So it is not easy to compress it or to stretch it because the value of spring constant is higher. Okay, but for N spring, since it has lower spring constant, so it is easy to be stretched and compressed. Okay, now let us try to look at this statement over here. If spring constant is higher, I can write higher here, it is more difficult to be stretched or compressed. So that is the statement that you need to understand. The next thing we're going to look at the example. What is the extension of spring N? Okay, now we are considering this spring. If the force applied is 15 Newton, we already have the spring constant here, so we can apply in the formula. F equals to Kx. Okay, X equals F over K, and F is, in this case, is 15 Newton. So 15 Newton divided by, we have calculated the value for spring constant of N. So it is 2 Newton per centimeter, Newton per centimeter. So the answer is 7.5. Newton here can cancel it out. So you have 7.5 centimeter. So that is how you apply the formula. And remember, don't forget the unit, because I found that some students, they always forget to write the unit in their calculation. Remember in physics, if your calculation is not included with the unit, it is considered as wrong.